Hello, we are Team 3 from class CSC340 of spring 2021. My name is Jia Lee.
My name is Rohan.
I'm Ralph.
And I'm Christopher.
This project is the project that we designed is to take two different files, weather.csv and catwrites.csv, and figuring out if there's a correlation between how harsh the weather was to the price of the rides. What we learned from this project as a group is mainly one, our communication. We felt as if we could have done a better job communicating on which part we had done sooner in order to finish and start putting together our project. We also had a team member who had dropped out of the class, which was unfortunate, and we didn't have much communication coming from them as well. One major obstacle that we had encountered during this project was whether to use arrays or vectors. In the end, we decided to use vectors since vectors are dynamically sized, while arrays, we had to declare the size at the beginning. Another major obstacle we overcame was creating the graph in Excel. Since we had a lot of data, we decided to shorten the amount of data we used to make a graph to just 1000, since initially Excel was constantly crashing due to too much data being used. Go.
Hey guys, my name is Rohan, and now I'll be talking about what I worked on for our project. So for our project, my job was to create the data structures that we would use for our project, create the header files for most of the classes, create the user interface, and help debug the program. Our group decided to use three different classes. The three different classes that we used were ride data, weather data, and all data. Our ride data class would store the data from the ride data CSV file. The weather data class was for the weather CSV file, and all data combined the data that we would use to answer our question. For each of these classes, the variables are all private, and in order to retrieve and set the values for each variable, we made sure to create public set and get methods. I also created a header file for all the classes so that we could link these files to our main.cpp file. In the main.cpp file, I also added a small user interface where the user can select from different options such as group, which gives our group information, export, which exports our data into a CSV file, or quit, which exits the program. Something I learned individually as a team member was that I should debug my code and make sure it works fine before passing it on to my group members, because otherwise it may cause confusion and lead to more complicated errors in our program. A major obstacle that I encountered as an individual was that I was having trouble thinking about the information that we would need to store in variables in each class and how I would design these data structures. This was a lot easier, however, after discussing it with my teammates.
Hi, my name is Jia. So my part of the project was to read two data files and store them into their own vector class. Then lastly, combining both vector classes based on their time and location into a final vector class called final data. The first method I created is called the read weather data method, which takes in the weather data class called raining as parameter. What this function does is that it reads into the weather.csv file. And because the file that we use contains a lot of data, we set a time for where we want to start collecting the data from, which would be this value right over here. After the program finds the data that is after our set time, the function then converts the corresponding elements to their correct data types. Because we use getLine function, everything that's being stored will be as a string. So instead of storing temperature, wind, and rain as string data, we use the std, which string to double, and we store that as a double instead. Then lastly, we push back the current weather object into our raining vector class. When all the data is read, the file closes and the loop finishes. The second function, read-write data, works the same way. The only difference is that the data that's being stored is different and it has more than the one that we use in weather data. The last function, called combine data, works a little bit different. This function takes both vectors that we have created, goes through a double loop to see if their location matches and if the time values are within the same hours using the function compared time. And this function was created by Christopher. If matched, the corresponding data from each vector will be stored together into a new vector called final data. As an individual, I learned a lot of different methods from recording data to storing data. At the end of this, I got a lot of practice on C++ functions that I would not have if it wasn't for this assignment.
As well as the setup of GitHub for us to share our work and the write-up that goes in depth of how we worked on our midterm project. So the two files that display our work when running this program would be display.cpp and display.h. In display.h, this would serve as a way for main to utilize the display method, and in display.cpp, this holds the code to output the work we did. It starts off with main calling the display function when the end user decides to export data from all data, putting the combined data from ride data and weather data in a vector of all data type named final data. From there, an output file stream variable named display weather increment score was declared to create a new CSV file named prices and increment score.csv. A header is set up in two separate rows, where one row would display the prices of Uber and Lyft, and the other row would display the increment score weather. Afterwards, a for loop is used to call the getPrice method, which gets the prices of Uber and Lyft, and the incremency score method, which gets the increment score weather, where a sample size of 1,000 entries was obtained to make it easier for the chart to answer the question we proposed for our midterm project, and to lessen memory usage, as I had experienced when outputting all the data instead. In the end, the new CSV file is closed to prevent it from being left open while unused. What I learned from this project, personally speaking, was files work when it comes to outputting the data we pull from the two CSV files we use, which are cabrise.csv and weather.csv. It was pretty nice being able to format the table the way we as a team want the table to look through coding. And last but not least, one obstacle that I had a little bit of hard time through when working on the display.cpp file was trying to figure out how I'd be able to output the two pieces of information we need, which are the prices of Uber and the increment score of weather, onto a new CSV file. And through the help of my teammates, I was able to solve this issue by creating a for loop that calls the getPrice and incremency score methods in order to get the data and place it in their respective rows.
Hello, I'm Christopher Torres. I was the leader of this project. And the main thing I learned is just how important it is to both lead and to create lots of amounts of documentation and forward planning for how to do projects like this. I tried my best in directing what kind of data types would be made and what methods would be used and how we would go about collecting the data and combining it. And despite my efforts, we still needed some extra time to finalize exactly what we needed that cost us overall in the product and debugging. And that was the main things I learned doing this.
All right, over here is our user interface. So right over here, when we type group, it will print out the group name. And when we type export, it will export the data onto a sort file, a sorted price and rainfall.csv file. And then when we click quit, that's when the program ends.
There were two methods I worked on within this project. The first was dealing with the timestamps that were recording the data. The timestamps were Unicode timestamp that were very long, like 13-digit numbers that were not human readable. So I made a method to transform those into a way that we could figure out which hour they pertain to and match the ride and the weather data to the same hour. I also made an inclemency score method that measured the overall inclemency or harshness of the weather during that time, using how harsh the wind speed was, how strong the rainfall was, and how far temperature was from the average. Using that inclemency score, we took the data in for that and compared it to prices. As you can see in this chart here, the prices are displayed along the y-axis, and the inclemency score that I use is along the x-axis there. So the higher the inclemency score, the more inclement or harsh the weather was. And as you can see in this graph, unfortunately, there wasn't much of a correlation between how much prices rose and how harsh weather was.